Makefiles. How do they work? Let's go to WSL and see. We will let's do make dir makefile tut, of course, because why not? Cd make tab good. Let's just go into Vim. I'm not that familiar with it, but I'm familiar enough to do a few things, and we'll set up our environment now. So what we need is a vertical split, because I want to have a Makefile, then I want to have a terminal window. So Control W right, moving between windows. Let's split this one as well, vertical split. In here let's do terminal. So this one will get us into terminal. Control W down, because we want to close this, Shift Z, Shift Z. Now Control W left. Let's start with the edit Makefile. There we go. What are Makefiles? Makefiles are essentially a list of recipes of how to build targets. And target could be anything. It could be build, it could be run, it could be timed run, it could be run attached to a debugger, it could be install, it could be help. Oh, let's start with the help. Let's say just we don't have a Makefile yet. If we run make, it will basically tell us exactly that there is no Makefile found. So let's create a simplest Makefile possible, which would be a target would be help, and for this target it will not need any dependencies, so whatever comes after colon is empty in this case, and the next line would be what to do, the recipe itself. It is important to note that this is the place where Makefile is extremely sensitive to using tab versus space. So this is a tab, never a space, it's always a tab. If your editor replaces tabs with spaces in this particular place, you'll have a bad time. Let's say that we are just doing echo something like hello Makefile. Easy enough. Let's save that and run make. This time what we see is two lines. First line is the command that was executed, and the second line is obviously the result of the command. We would like to suppress the output, which is done with prepending the command with an @ symbol. If we save this one now and run make, it will just output the second line. And again, since it does not have any prerequisites, it will just run. Now we can achieve the same. We say make help. Now we are specifying exactly which target to make. Since we only have one target right now, it doesn't really matter, but let's say we have another target. For now we'll just have a phony one, which is build, which says echo build is invoked. Let me be simple. And now if we just say make, what it will do, it will run the first recipe. Build is invoked. I think invoked is spelled with a K, doesn't matter. But we can still say make help, which will run the recipe we want, which is the help. Or obviously we can say make build, which will once again run the first recipe. If we want to say that I want help to be my default goal, right? So we can say default goal, and we say equals help. What that does is that now if I run make without any parameters, without specifying the goal, it will automatically say, oh, I know the default goal is help, even though build is the first one in the list. Control W left. Let's actually have a rough idea of what we want to have in here. So let me just say available targets, and if I were able to spell it, would be better. We can have more than one line in here, again tab, never a space. And the first one is obviously build, which says build executable. We will work on that next. And the other target we have is obviously the help. That is to, let's say, show this message. Obviously, we will also have, usually Makefiles have a target called all. It's basically by convention, doesn't have to, but by convention there is a all target that essentially does everything. So it build and run essentially. With that, we probably also want to have a clean if we want to sort of reset our build environment, clean up all the unused files, and just basically clean up after ourselves. Remove build files. And also, yeah, I'm making that alphabetical apparently. And then we will have the let's say, what are we missing? Run, which will just run the executable, and we will see how that run will actually make sure that the executable is up to date, and if not, it will cause the rebuild. And the last one would be well, this is it for now. Just to see what we are working with, if you say make, so let's say somebody comes into our build system, doesn't know anything about what our make does, they just do make, expecting something, and the something would be the explanation of what it does and what it can do. Now it's time to do some actual make, right? So let's go to the right window, which was with the Control W, right? And let's edit main.c. Let's have something simple. I think the simplest one would be just to print something. So include stdio.h, obviously, but again the spelling is hard. And we have an int main void which basically says printf, and no surprise there, hello world. Probably end of line is good here. And well, just return 0, right? Don't get fancy. So how would we go about it manually without a build script? We would probably do something like gcc -o. Well, actually, properly, if we were to do it properly, we would do the compilation step first and then the linker step second. So let's split it right now. So main.o coming from main.c, that will produce our main.o. There it is, it's right here. And then we link it up with, again, gcc main.o -o and let's say hello, right? Just to be something. And if we look at it now, we see the hello, and if we run it, we should expect hello world. There we go. So how do we now tell Makefile the same things? How do we build it? The build will essentially depend on, well, let's not do dependencies yet. Let's just start with this. So let me get that. Let me do the tab character. Let's just repeat the same exact commands just manually for now to see where we stand. -o main.o main.c, and I will not suppress the output for now, mostly because we want to see how it goes. And then we'll do the linking, which is coming from this, and it's called hello, right? And then actually, let's do the run target now, since we can. So run target depends on the build step. If the build is successful, then we can do the execution of the file. So hello. And also, I guess it's a good time to do the all, which is nothing more than just run. So you see, we don't even need to specify any commands here, because if we ask for all, it will just unconditionally do the run. And unconditionally in this case essentially means that the all target does not produce a file named all, and the run target does not produce the file named run. The same actually is currently for the build. The build itself does not produce the file named build. It produces a file called hello, but not the file called build. Those are what's called a phony target. Those are the targets that do not produce an actual file where the Makefile can compare the timestamp to figure out the dependency, whether dependency has changed and the step needs to be taken. We'll get back to that in a short while. But for now, we'll just specify that all, build, help, obviously, run, and you know what, clean will also be in this category, so I'll just add it now. Clean is also a kind of target that does not produce a file with that very name. So I did change it, so Control W right. Now if we say make, let's say run, right, it should, and it did, run gcc compile, gcc link, then it did run the hello, which produced the hello world. Okay, good. What do we have next is let's have a little bit of maintainability upgrade. So for example, our target name is hello, that's the program we are running, and it will go into our current directory. Actually, what I would like to have is in here, Control W right, I would like to have a build directory where those hello and main.o files will go into, so we have a clear separation between our source files, which is main.c and Makefile in this case, and our target builds, which will also make it easy to clean, because we can just remove the build directory, right? So something like make dir build and produce the output into there. Let's see, going left, which let's specify a few of those things. Well, let's say target name is hello, obviously. Target dir would be build, also quite obvious, which makes our target name to be, and let's use the variables, target dir slash target name. So it should be quite obvious what's going on here. Our target variable now it basically says dot slash build slash hello. With that, what we can do is we can say that when we run, we don't say dot hello, we say target, right? Which in case we do change the target name to something else, we don't need to think about it, it will just change here automatically. Also, the build currently, actually, quite explicitly, it depends on the existence of the main.o file, and let's just say main.o, it does depend on main.c file because of this. What we have done here is basically we said that the run depends on a build step, and build is not an actual target, it's a phony target, so there is no file timestamp to compare, so it just unconditionally runs whenever I ask for the run. Now it goes to the build. The build recipe says I depend on the main.o existence. If the file main.o is not there, I will create it by running gcc main.o-o hello. But if it is there, if the main.o is not there, then I need to find the recipe which is right here, which says main.o depends on the existence of main.c, and I would like to compare the timestamp. If by any chance main.c is newer than main.o, then I will run this step, which is to compile, which will come then to this step, which says that, oh, my main.o actually changed, and I need to, well, I cannot compare it to the build because build is a phony target, so it will always execute this step, at least the way it is written right now. So what we have here is build depends on main.o, and main.o depends on main.c, and this will just trickle down economics. Now the target is great. We have target name, target directory, and the thing about that is the target directory, right? So we do need to place our main.o into the target directory, right? The same as for hello. So the way we can do that is we can specify that it's a target dir main.o, which comes from main.c, and then the build is coming from target dir main.o, and we are building, of course, target dir dash main.o and put it into, well, we can say target, right? Because we already specified that our target consists of target name, target dir slash target name, and then we come to here. Instead, without going too far, let's verify what we have so far. Let me do a quick check of what we have over here. What we have over here is build and hello. Let's clean up the stuff. Build. Also I want to remove hello, and what else? I want to remove start.o, I suppose. What we are left with is a list of source files. Okay, good. So now what is going to happen is we're gonna fail make run, and the reason we're gonna fail is the build directory does not exist. So what we need to do is whenever we encounter this step of building the main.o, which actually should be main.o in the target directory, right? So the target directory is where we put the main.o into, which actually did work. We just could not do the build hello, right? Because this one we forgot to specify the directory. So if we look into what we have, you would have the o file, of course. Remove .o. Now if we do the make build run any all, it will fail to even build the main.o because the build directory does not exist. To fight that, what we can do is we can say the first step in here is to just call the make dir dash p, and our directory is target dir, right? So let's say target dir. At least that's one way of doing that. Let me just go here, make all, much better. What we have here is it created a build, and inside the build it would have our hello and main.o, and obviously it has also run it. There is a hello world output from here. Now it's probably a good time to add the clean target, so we can clean up and redo things if necessary. So clean would not depend on anything, and what it would do is again a tab character here, not a space, rf, and of course you want to just remove the whole target directory because that's the easiest and simplest way of doing things. Save. So now if we do make clean and ls after that, we see main.c makefile but no build directory, and if we do make build, it will create the build directory right there. Next thing we want to do is to have the list of objects Makefiles, which for now includes the target dir main.o, and then what we can say here is getting objects. So the build depends on all the object files, which will have more than just main.c, and it's time to use automatic variables. There are quite a few existing automatically available variables, which again we can do. So this one depends on the list of object files, so we need to put the objects into here. We can say objects, but more appropriately we could just say automatic variable caret, which essentially says that give me the list of all the dependencies for this particular recipe. And the rule for the parentheses is it can be omitted if the variable is a single character long. So by convention, more or less, this is what it's gonna look like. What it says now is that when we run the build recipe, we look for all the objects in this list, which only contains one file for now, which is in target directory main.o, and if they do exist, we run gcc providing it with the .o and the target, and if it does not exist, we are looking for how to build that particular file. And since we only have main.o currently, we will know that we need to go here. However, this is a pretty generic rule that should work for other files, not just for the main.o, right? So what we can say is get me, so the generic rule for all the files which end with the .o would be to get a corresponding file with the same name but the .c extension, if necessary create a directory for it, and then we say that we want to compile that into the target. So that would be automatic variable at. Look at the target, actually does look like a little bit of bullseye and a circle around it. I guess that's why it was called the target. And it is being built on the first dependency of the dependency list. And the reason for the first dependency is that we can specify more than one dependency in this list. For example, you may want to say that anytime a Makefile is updated, we may want to recompile all the C files anyway, because it may change some flags, some parameters. Speaking of flags, let's add flags here as well, because we all know flags are great and some of them are better than others. The ones I personally prefer would be all the warnings and also extra warnings. And let's just for fun make it O3 optimization. So what we can do now is when we do a GCC call, we say do it with flags, and of course the same flags, because there may be some flags for like link time optimization in that list, we will be using in here as well for consistency for the link step. And also GCC itself, in case for whatever reason we want to change our tool chain in the future, we don't want to go through all these places and replace them individually, we will just say that we have by convention it's called CC, and now we can say that just invoke our compiler and just invoke our linker in here to do the job. Let's see what we have so far. So make clean and then we do all. This is what you can do with the make. You can specify multiple targets one after another, which will be executed in a sequence. So it will first do the clean and then it will run the all. What we have now is that the build main no such file directory. That is correct, because our target, the list of objects, already has the target dir in it, And when we were in here, no, over here, this is where we went wrong. So this guy is not necessary, because we know that our target objective of this recipe already is prepended with the proper directory placement. Let's do that again, make clean all, and we do get our hello world properly. Fantastic. Next thing we do is the list of sources. As I said, for now we only have one file, but if we add more files as our project grows, we don't want to every time go here into Makefile and change the list manually and keep it up to date. It's just tedious, error prone, and let's automate things. In fact, let's say automation, right? So let's say automation starts here, and it should be obvious that using the hash makes a comment which can also be used at the end of the line as well. But by convention, it's usually the full line comment because of sometimes there could be a weird corner case, and you don't want to deal with that. Now, coming to here, what we were trying to do, we were trying to get all the sources into the list. So for the sources, we can say, actually let's put it in here. So our sources would be coming from the list of all the files we can file in this directory with the extension of C. So for that we can use a wildcard macro, which we specify in such a way that look for all the C files in this directory, and with that we can actually now have the object files generated from the list of source files to make it automatic. So for that, what we can do is we can get all our source files, we will put them into the target directory and append the .o extension for them. So this is how it's gonna look like in the shortcut syntax. We take the list of sources, we take what's in that list, and we prepend it with the target dir, then use that same file name and extension and the path. If it was in there, it would also use the path, and append it with the .o extension. What it will result in is that this file will now be .c.o. That's basically the only change it's gonna cause. And with that, so now we have our sources automatically generated, our objects automatically generated, we have our target dependent on all the C files, corresponding C files, and the Makefile itself. And we also do have the build, which does the linkage, and the run, which just runs, and all, which does all that. So let's see what we end up with. Let's clean and run the all. We are still good, so it's still working. We are still generating all the proper things manually, I mean automatically. And with that, let's move on to the next one, which is let's add another library. That's what we're gonna do. So let's say we have make dir lib1, and let's go to the rightmost window and let's split it, and let's add lib1 lib1.h, and also let's split it vertically and add lib1 lib1.c file. Now let's resize windows a little bit, so that will be Ctrl+W more than, and I'll have it a few times. I think that's enough, and the same for this guy, just to have a little more space to work with. Now Ctrl+W right, Ctrl+W up. This is the C file and this is the H file. So let's start with the H file. lib1.h, what do you want in there? Let's say we just want to provide greeting string for the printf in the main. Something very simple. So of course we're gonna start with pragma once. We don't want that to be done multiple times, and we say extern const char star greeting message void, right? Nothing fancy. And in here what we will have, of course, we're gonna have the include lib1.h, no way around that. And also let's specify static const char star const greeting, which would be hello from lib1, I suppose. And the actual function that does the job, const char star greeting message void, that does nothing much, obviously, just returns the greeting. Should be easy enough. Now let's save that. Let's I don't remember if I saved that, actually I don't remember, so colon WA to write all. Go back, Control W left, Control W left. Now what we have, oh right, we do need to change the main function as well, I mean file, right? So let's include our lib1.h, because instead of hello world we're gonna have the %s, and give me what's coming from the greeting message function. That looks appropriate. So the problem now would be that when we do the make build, our main has changed, so it's trying to rebuild the main, and it did rebuild the main, but when it was linking, obviously it could not find the reference to greeting message, which was in lib1. So how do we tackle that? Well, of course we can add that into the list of sources, but when we add more directories to our build tree, we would like to just have those directories automatically processed by the build script. So let's start with getting the dirs directory specified as being a dot and lib1, because that's where our files are, or we can say ./lib1, doesn't really matter in this case. And now when we get to the list of sources, what we will do is we will use the for each, which is used this way. So for each dir from the list of dirs, what we're gonna do is run a wildcard in the directory like that. And of course we need an extra pair of parentheses in here. So what it does is, again, for each item in the list of directories, which are white space separated, we run the wildcard finding all the C files that are in there, in that directory, which should produce more files for us to build, to work with. And here is a small tiny debugging tip for the Makefiles. How do we know what is the list of sources, so we can actually take a look at it? There is a info macro that basically says sources and sources. And you know what, just to make it easier to read, in case list of sources is empty, I'll put it into brackets. And we can do the same for objects, just so that objects, and of course in here we will have to say obj. So we will see what is the list of objects and sources that we have. And I don't remember, did I have to include those into double quotes? Most likely, but we'll see if it fails. No, it works. So the sources, we have main.c and lib1, lib.c, which is correct. And the object files it produces is build main.co, build lib1, lib1.co, which is also correct. Then we removed, we make dir, we run this, we run that, and then can create build lib1c, no such file or directory. Right, because we were creating just a target directory. What we need to create instead is we need to create the directory that matches the path of that target that we are building, but only the path portion of it without the file name. And so the automatic variable for just the target is an @ symbol, but if we append a d to it, it will make it into directory name. Or if we use the f, it would be the file name. So now, if we run that make build, it should properly create the directory as it's supposed to be. And if we make run, it should produce our hello from lib1, which is correct, because that's our message now. Hello from lib1, which is specified over here. Wonderful. Now, let's say, just update the timestamp in here for this header file. And when we say make build, it will not recompile the corresponding C files, which both depend on this header file. Why is that? Because we didn't specify the dependencies. Now the compiler has a built-in support for us, which says, if you ask me nicely, I can create files which will list the dependencies, which will let you know which header files affect which source files. So we can just add it into this list of flags, or we can just say flags plus equal dash mmd. That's the one which will produce the list of dependencies. Now it's good to produce them, but we also would like to use them, so we don't need this, I suppose, anymore. In order to use the dependencies, what we do is we just basically include well, you know what, before we do the include, let's have a list of dependencies, which is essentially the list of our object files, but we do want to replace the .o extension with the .d extension. That is it, nothing more fancy than that. And then we can just include the list of dependencies into our list to be taken care of during the build. Now if we do make clean, or even just make build, it will fail. And the reason it will fail is it's a little bit obscure, null character seen, the rest of line ignored. But the thing here is that the include failed because there were no .d files, and by the way it's not 0, it's supposed to be an O. There were no .d files created during the previous run of the build, right? It's the first time we are running it, so there are no dependency files. So what we can do is we can just ignore that error by prepending it with the minus, and we will say that now the include of dependencies does nothing. It will not fail. Even if it fails, it will not cause the Makefile to fail. However, as an extra level of defensive programming, what we can say is we can compare the list of dependencies to an empty string. And the way to do it is, first of all, we can use the strip of all the white spaces from dependencies, and we say if not equal of that list to an empty line, then and only then we include it. And let's end it with an end if here, and also we can just indent it a little bit. So now what we have here is when we generate the dependencies list, we will include it if it's not empty, and we will just force the system to ignore any errors that may be caused by this inclusion. So now if we do the make build, it should missing separator, Makefile line 16 if not equal. So we did miss a space over here, if not equal. We should be good now. There we go. So make all, which will build and run, and hello from lib1 again. So what we have now is the list of dependencies that is gonna be included into our build system, which obviously when we do the make clean doesn't make sense to include that. It's a minor optimization, but still we would like to just to show you what to do with particular commands which are specific to particular targets being called. So if not equal make command goals clean. So if it is not a clean, I did miss open parentheses over here. So if we are not calling the clean, then we're gonna do all these shenanigans and if. Again, it's not causing too much problem right now, but it's a generally more clean way of doing things. Now what we have is let's go here, make clean all, should build and produce the hello from lib1. The output is getting somewhat verbose, so let's take care of that by suppressing the make dir message and the invocation of the linker, compiler, all this good stuff, and even that, I suppose, and this. We don't want to see any of that, but we do still want to kind of like have an indicator of what is it we are building right now. So what we can do is just echo silently our first dependency, which would be the less than sign, and we can probably see what it looks like. Make clean. So make clean will just silently do the thingy, and make all should say we are building main.c, lib.c, and then it produces the output from the binary. Let us add C++. Very often we have a mixed project, so let's see how that looks like. First of all, by convention CXX, we're going to be using G++ in here, and it doesn't matter that much yet, but what we're also gonna do is we'll have lib2 directory, and let's work with that first. So let's go right, let's split it once more, because we want lib2.h, and vertical split into lib2.cpp. There we go. Again, I want to make this slightly wider, and the same here. We'll probably want to include lib2 for some reason, right? If we're gonna use it. And let's see, how do you want to handle that? Let's say lib2 will be, oh, I don't know, Fibonacci. I guess every developer has to write a Fibonacci program at least once, right? So let's do that. Pragma once. Now we want to have extern void print fib, which gets an unsigned n, and of course let's just have an extra space here. And when we cannot open file for writing because we have not created the make dir lib2, of course. So now if we save all, it should work, right? So lib2 cpp, let's see, of course we're gonna say include lib2.h, obviously, and we're gonna have the Fibonacci. Let's see how we're gonna handle that. For now, let's just say this program print fib unsigned n. For now, it will just do a very stupid thing. It will do stud cout. It will say Fibonacci of number n equals For now just n, since we're gonna change it later, and the end of line. So now what we have is we have a list of directories lib1 and lib2, and obviously in our lib2 the file is lib2.cpp. So what we need to do is we need to take care of that extension as well, which, you know what, let's do that. Extensions list will now include C and CPP, and who knows, maybe we'll add assembly later, or Pascal, or ADA, whatever. Now when we get to the list of sources in here, we do traverse all the directories, but we also want to traverse the list of our extensions. So we can compose those, and we can say that for all the directories that we have, we're gonna have another embedded inner for each, which says for each extension from the list of extensions, what we're gonna do is do the wildcard of the dir, and in here we will say, no surprise, ext. Did we get all the end? One more parenthesis over here. Okay. Now when we get to the list of files that we need to build, we know that we have a rule to build the c.o files, but we don't have a rule for building cpp files. So let's do that. Let's shift W, visual select, then Y for yanking, and then we just paste it after this line, and let's modify it to our needs, which is cpp over here and the cpp over here. Of course we want to run the cxx toolchain, and you know what we can do, just get a little bit fancy. We can say that the C files are being built with the C17 standard, and the CPP files are being built with, I don't know, C++23 standard. So we can now separate those into C and C++ functions. Although our flags are basically the same, nothing wrong with using them as is. Although if they start diverging too much, we can have separate flags for C, separate flags for CPP, which will also have a common flags section, and then we'll have flags CC and flags CXX, which are specific for each platform. It will almost work. Let's see what the error is. So make build. Oh, right, wait. Before we go there, we do need to use that new thingy in here, right? So let's print Fibonacci of 1. Not very imaginative, but it should show the problem with that approach. So make build, you will say error, cout is not a member of std. Well, that is true, and that's a different issue from what I was expecting to get, so let's fix that one first. Of course we need to include iostream. Okay, now let's make a build. So it will build, but then we have a wall of text which says basically undefined reference. This is because the linker we are using is a C. It doesn't understand all the intricacies of the ++, so it's easy to fix. Just invoke the CXX linker, which understands both C and C++. So now if we go here and we say make build, it should successfully build, but in defined reference to print aha. And here is a secondary issue. When we were including lib2.h into our C++ file, it was fine. The extern void worked fine. But for the C file, we do need to say extern C. And obviously we need to now craft our header file so it adheres to both of them. And the difference is right here in this line. This would be C or empty, depending on whether we're in C++ mode or not a C++ mode. So let's do it directly like that. So if we have C++ defined, then we do need to say extern C, otherwise we are good. And now when we build, it should work much better, and it did. So if we do the run, it obviously says hello from lib1, and we have Fibonacci of 1 equals 1, which is surprisingly correct, but it's gonna be invalid for other numbers. What we have next is let's actually implement a more appropriate Fibonacci number. Let me do it real quick. We don't want that to run forever, because if we just, let's just do the stupid one and then a smarter approach. So what we want is a static after Fibonacci, which gets unsigned n, and when we produce the number, we say output whatever comes out of fib, and then here the absolutely naive straightforward implementation is if n equals 0, well, the first number is also 0, right? So n starts with 1 actually. If l equals 1, then return 0. Now if n equals 2, we do return 1, otherwise we return a recursive call of Fibonacci n minus 1 plus Fibonacci of n minus 2, right? That's like a canonical way of doing that, which again, it's explosive recursive call, which will slow down significantly. And let's see how bad it explodes. So let's add a bit of a loop in here, right? So let's say for unsigned n equals 1 and less than 10 plus n, for now just 10. What we're gonna do is print Fibonacci of n, right? And let's end it with print f of no, we don't need an empty line because Fibonacci always prints 1 per line. So let's see how that works. So make run, it should rebuild. It did rebuild. Finb, okay, there was a mistake over here. Fib and minus 2, right? So with that taken care of, we do get our numbers. Do they look correct? 0, 1, 1, 1, they do look correct. 2, 3, 5, 8, 13, 2. Yep, they do look correct. However, if we were to make it like 20, for example, right? R2, it will, I don't know how long it's gonna take, so let's implement the last target, which is called timed, which will produce the timed statistics of how our run behaves. Timed, which says run the executable with time stats. And the way we're gonna do that, gonna be over here. It doesn't really matter, but I just like it to keep it here. So the timed would depend on a build, and the way it's gonna work is it's just gonna do the time. Don't get too fancy, all the tools are available. And now if we say make timed, we will see that it took some amount of CPU clocks and all that stuff. For the timed, we don't really need to have the output, right? We don't need to see the numbers. We just need to know how long it took. So let's just specify it explicitly. We say that we don't want the output. We just want timed, and that's what we get. We have a build, so we can run it again and again and a few times more. Now if we change that into 40, I don't know when it's gonna be really noticeable, but let's make 40. And now we run the timed. It's slightly noticeable, but let's make it 60. Let's see what my computer says. And now it's noticeably taken way longer. You see, it's taken so long that I'm probably gonna just break out of it. I don't know how long it's gonna take. Just for fun, let's make it 50 and see whether it was as bad as 50. And it is as bad as 50. So obviously the problem here is in this code, which is quite stupid. So Control W minus, let's get more space, because what we want to do is introduce a bit of it's called dynamic programming, I believe, where we remember the results of previous calculations, and that should make things faster. You see, it's still running the main.c, and then we'll see how long it's gonna run. Oh, it finished running. Oh my god, that took a while, a long while. So what we're gonna need is a vector, obviously. Now we're gonna start using real C++ features, and let's quickly update our function. Okay, so that looks good. Let's save all, go back and run this again. Oh right, minor details, I did need to say 0, which I forgot somehow. 0 over here. So now if we run the timed, see, even with 50, and I would imagine 80, which would really take a long time, it should be more or less immediate right now. So I don't know whether those numbers are valid. Let's just say make run. Those are some big numbers, and if we scroll up, we cannot scroll up, not in this environment. Oh, never mind. I do believe when we checked the first initial values it was correct. So you see how the numbers grow. We can take a look at that. So let's stop worrying about the Fibonacci sequence and take a look at what do we have in our Makefile, because this is all. This is it. So what we have is, first of all, ls. Let's do the make clean and take a look at what we have. We have null. Oh yeah, it was supposed to be null single L, not double L, haha. Rem null, and let's just make sure. And now if we say make timed, it should not produce a null file. It produced a null. I misspelled something here. Doesn't really matter that much, right? So obviously I'm coming from Windows environment. That needs to go into dev null, which would be what, dev null. So now if we run the make timed, actually we needed to remove permission denied. So screw that, I suppose. I'm not gonna fight that too much because it's not the point of this video. I'll just do the make timed and it will produce all this output. More importantly, make clean, and also let's remove this null thingy. Let's see if we are clean now. Right, so what we have is main.c, which is not a C++ file, it's a C file that includes two libraries. One is a C library, another is a C++ library, which are being built as C or C++ targets respectively. We are using two different tool chains to build them. One is GCC, one is G++. We do have our target name. Actually, let's rename the target name now into Fibonacci, because that is what it is, right? It's not a hello anymore, it's a Fibonacci. And this is where you see the power of specifying the desired outcomes as variables, because I needed to change it in one and only one place, and as a result I can still run it and it will build the appropriate thing with the name fib. If I do ls build, I'm sure to find, well, if I were to spell it correctly, I'm sure I will find fib instead of hello, and there it is, right there. We do specify the target build, which is useful when you have multi-bit build target system. For example, if you want to have a separate make rule for debug build versus release build versus profile build versus profile release, profile debug, if you want to run it and attach to a debugger session, or if you want to run a daemon and then attach to it from here. So you can have as many targets as you want in your Makefile. It's quite customizable, and when you build different targets like build, release versus debug, for example, you do want them to be in different target directories. So what you may end up doing is, if you're running the target for debug build, you would say my target dir is build/debug, right? And for release it will be build/release, and then you have your like clear separation of where your build files are in case you need to rebuild just that particular one instead of the rest. Then we have a list of directories of where to look for the source files and what are the extensions for those files. If you were to add another extension into here, you would also need to add a rule of how to build this kind of file, which is self-explanatory, I suppose. It's understandable that it needs to be done. We do specify flags. We see that we can add more to the flags. We then go through the directory and search for all the sources that we need to take care of. We create a list of object files, because then the list of object files goes into this dependency over here. When we need to link, we are looking for all the object files, and if one of them is not there, or any of them is not there, then we are looking for how to build those object files, and that would be in one of these rules that we have over here. And we also have this like the rest are easy, and we have a help, because we do want our default goal to be help. For people that don't know what our Makefile does, if you just say make, it will say, hey, hello, this is what you can do with me, and you can build all this stuff. A few last things to talk about would be, first of all, you see this repeating code, make dir -p, creating the directory. I honestly don't like repeating code. I'm a big proponent of the dry rule, do not repeat yourself rule. So with that, let us specify a macro called, let's see, how do we want to call it? We want to call it dirguard, I suppose. Yeah, that's a good name, dirguard, which would be just a make dir -p and the name, which is the directory part of that name. It's usually a good idea to put this into double quotes, just for some crazy people that want to have a directory with a space in it. In this particular, well, for example, if you're running in a Windows environment, or you are running in the deep like subdirectory and the parent directory has a space in it, you don't want to fail to this little stupid thingy when you're making a directory. Another thing to note here is the use of an equal sign. If you see everywhere else when we were assigning variables, we were using the colon equal, and the difference is crucial. Using just an equal sign means it's lazily evaluated, because, for example, if we get here and we run our dirguard command, we are executing in the context of this recipe. We will not know the value of the directory in here. We would only learn it when we are running it right here, which means that we need to lazily evaluate it when it is used. In contrast, the rest of this, like CC, CXX, target name, and all of this, we know exactly what the value of those is right at the time when we define it, so we can aggressively evaluate it right away. It's not dynamic, it's just set in stone. You can, of course, override the variable later, but the value that is being assigned to it is an immediate one. If, for example, you change the target name in the next line, like you say target name equals blah, it will not affect the value of the target because it's already been set in stone. So that's what the difference between the immediate evaluation and the lazy evaluation is. The colon equal is an immediate evaluation, and just the equal is delayed lazy evaluation. Another thing we need to remember is just a general maintenance thing, but timed is also a phony target. It's not a target that produces a file with its name. So if we go here and we say make all, since we did change Makefile, it will redo and rerun and all that. Make timed also do similar thing, and ls will produce the same clean environment that we had before, where everything goes into build like that. Also, let's take a look, one final look at this place over here, the build. So the build, realistically, it depends on a target, not on the object files. So let's be explicit about that. When we are asking for the target, this is the one that depends on objects being available. But this guy over here, the build, depends on target's availability, and of course this line D goes into here, P, because when we build the target, we want the object file. So this will allow the build system to actually compare the timestamp and say if our target is outdated, if the object files are newer, then and only then we run the link step, otherwise we don't. And since build is an unconditional target, it's a phony target, it will just always run, but then it will now check in here whether the object files are newer or not, which will obviously trickle down to the source files all the way. So now, if we say make all, in fact, if we were to temporarily enable this, so we see whether it is being run. So first time we make a build, it will do the build. And second, it should say yes, nothing to be done for build, and this is exactly what we want. We want the build to only be done when it's necessary. It is probably a good idea to have the link step actually explicitly. So we want to suppress this message, but we do want to say that we are doing it. So let's echo linking and our target, right? So the target would be the automatic variable target. And now if we go here, we say make all, it will say what we are compiling. Let me say make clean and then make timed, because I'm too lazy to change the source file. Oh, it's still producing this. Anyway, okay, I'm not too lazy. Let's change it back from 80 to like 20 so we see the output more appropriately, and make clean, actually make all, make run would do it. So what we have here is linking build fib, so we know what we are building and we are not as blind about that. And now that my brain unfroze with it from its fart, of course if you want to suppress the output of the timed run, which is over here, what we do is we redirect to dev null with a double L, not a single L. And now if we go to make timed, we should get a proper output finally. With that, thank you for watching, and I'll catch you in the next one.